Theorem 10.6 says equal chords of a circle are equidistant from the center. As you can see the figure, there is a circle, center is O, AB and CD are two chords which are equal in length. So AB, CD, their length is equal. We are asked to prove that they are equidistant from the center. These two chords CD and AB, their distance from the center is equal. And remember one thing, whenever we check the distance of any line segment from any point, it is always the perpendicular distance. So what we need to do, we would construct perpendiculars from center to fall on AB and CD. So perpendiculars are drawn. OM is perpendicular to AB and ON is perpendicular to CD. So let's begin with the given information. Given over here is a circle with center O, AB and CD are two equal chords. Okay, this much we know, and we need to prove that AB and CD are equidistant from center. And checking it from the figure, what can we say? We need to prove that OM and ON are equal. So we would have a construction. One construction is already done. Construction, let me mention the construction. First construction was draw OM perpendicular to AB and ON perpendicular to CD. Okay, first of all, this construction has been done, and second construction would be, because we need triangles, for that either connect AO and CO so that we get two right angle triangles, or connect OB and OD. Let's do it this way. So I am going to connect OB, and from the other end let it be OD. Observe these two triangles. We have joined OB and OD. Proof. First of all, let us see which triangles we are going to pick up. We have taken triangle OMB and triangle OND. First of all, AB, since it's equal to CD, I'll just mention it here, as AB is equal to CD, that implies half of AB must be equal to half of CD. Reason for this, because from center perpendiculars were drawn, and in the previous theorems 10.3 and 10.4 we did this concept that when perpendicular from the center to a chord is drawn, it bisects the chord. Alright, so AB and CD, since they are equal, from center perpendiculars are drawn, and those perpendiculars would divide these parts into equals. So half of AB would be BM or AM, but we are talking about triangle OMB, so we would mention BM. Half of CD would be CN or DN. Since we are dealing with this triangle, so I would mention DN. Okay, this result will be used while proving these two triangles congruent. So this I am writing here, OMB, OND, BM is equal to DN, proved just now or proved above, already proved, or anyway anything can be written. Second thing, angle of 90 in OMB, this is angle M, and OND angle N, each 90. And the third matching part will be these two radii. OB is equal to OD. They are radii of same circle. Which rule is it? Observe it carefully. There was a right angle, there is one side, then hypotenuse. Triangle OMB is congruent to triangle OND by RHS rule, right angle, hypot and one side. So if RHS rule has proved these two triangles congruent, what can you say about the remaining parts? Remaining parts means the sides, the angles. We are looking for these sides. Is ON and OM, are these two sides equal? Of course, because if triangles are congruent, we can undoubtedly say OM will be equal to ON. This is by CPCT, corresponding parts of congruent triangles. I'm sure this must be clear. It's one of the important results, will be used in many questions. Well, the next one is converse of what we did in 10.6. It says chords equidistant from center of a circle are equal in length. Look at the figure. There's the same circle, AB and CD are two chords. They are equidistant from the center. Now, as we have already discussed, that whenever we check the distance of any line from any point, it is always perpendicular distance. Okay, so OM and ON is equal. This is given. We are asked to prove that these chords are also of equal length. So we would have a construction. We would connect, I have actually done the construction already. We need to connect OB and OD. So I'll just mention it here. Join OB and OD. Now which two triangles? Triangle OBM and triangle ODN. Considering these two triangles, OBM and triangle ODN, matching parts, first one, OM is equal to ON, they are equal, it's given, this information is given. Then angle of 90, let me mark them as angle 1 and angle 2. Angle 1 is equal to angle 2, this is each 90. You can either mention the angles using all three vertices, or just to save time you can mark them by numbers. Choice is yours. And then comes the radii. OB is equal to OD. OB, OD, they are the radii of same circle. So which rule? Right angle, hypotenuse and one side. Triangle OBM is congruent to triangle ODN by RHS rule. And if these triangles are congruent, what can we say about these parts? The other parts, I'm talking about these sides, DN and side BM. This implies BM must be equal to DN by CPCT. But we need total AB. So should I double it? Twice of BM would be equal to twice of DN. Now what is twice of BM? It is total AB. And twice of DN will be CD. Why can we say that this is true? Reason for this. Perpendicular from the center to the chord bisects the chord. right? From center O, OM was perpendicular to AB. That means M is the midpoint of AB. So if BM, this side BM is proved to be equal to DN, then double of this, which is AB, must be equal to double of this, which is CD. So hence our result that chords are also of equal length, it's proved. Okay, remember, whenever two chords are at equal distance from center, they would be equal, and even converse is true. So hence it's proved. This is also important result that would be used in many questions, so just go through it very carefully.